Let us talk the advantages of SSTF. First, average response time decreases. Second, throughput decreases. Next up, the disadvantages of SSTF. First, overhead to calculate seek time in advance. Second, can cause starvation for a request if it has higher seek time as compared to incoming requests. And lastly, high variance of response time as SSTF favors only some requests. Let's go to the third algorithm, which is the scan. In scan algorithm, the disk arm moves into a particular direction and services the requests coming in its path, and after reaching the end of disk, it reverses its direction and again services the request arriving in its path. So, this algorithm works like an elevator, and hence also known as elevator algorithm. Given the following queue, 21, 76, 59, with the previous position 47 and the current position 65 with a given seek rate at 3 milliseconds. This approach works like an elevator does. It scans down towards the nearest end, and then when it hits the bottom it scans up, servicing the requests that it didn't get going down. If a request comes in after it has been scanned, it will not be serviced until the process comes back down or moves back up. The first track is 65 going to an elevator second floor. The second track is 76 going to an elevator third floor. The next track is 99 going up to an elevator fourth floor. After track 99 is track 59 going down to an elevator third floor. Next up is track 21 going down to an elevator second floor. And lastly, track 0 going down to an elevator first floor. Solving for total head movement, which is 99 minus 65 plus 99 minus 0 equals 34 plus 99, and the total head movement is 133. Next up is the seek time, where 133 is the total head movement times 3 milliseconds. And our seek time is 399 milliseconds. Let us see the different advantages of scan. It has a high throughput, low variance of time, and average response time. The disadvantages of scan. It has a long waiting time for requests for locations just visited by disk arm. Let's go to our fourth algorithm, which is the C-scan. C-scan algorithm, in which the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the requests from there. So, the disk arm moves in a circular fashion, and this algorithm is also similar to scan algorithm, and hence it is known as C-scan or circular scan. Given the following queue, 21, 76, 59, with the previous position 47 and the current position 65 with a given seek rate at 3 milliseconds and the return sweep at 10. Circular scanning works just like the elevator to some extent. It begins its scan toward the nearest end and works its way all the way to the end of the system. Once it hits the bottom or top, it jumps to the other end and moves in the same direction. Keep in mind that a huge jump doesn't count as a head movement. 47th track, going to the Marilao. Next is 65th track, going to Bacolod. Next is 76th track, going to Guiguinto. Next is 99th track, going to Malolos. Next is 0 track, going to Calacan.
Created using Powtoon.